3, Chapter 8, Section 2, the law of cosines. Now we still have two cases where we haven't talked about how to find missing parts of those triangles, and that's going to be side, 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 and side, angle, side. When you're given three sides or two sides and include an angle, you can't use the law of sines because none of those ratios would be complete. You wouldn't be able to fill out top and bottom of any of them, and you have to have one of them completely filled out to work. In such cases, we're going to use the law of cosines. Now we have two forms here, the standard form and the alternative form. The alternative form is where they've just solved for the angle. You can use whichever one is appropriate. When you're given three sides of a triangle, it is wise to find the largest angle first. Now, how do you know which is the largest angle? Well, the largest angle is going to be across from the longest side. So, if you know the cosine of an angle, you can determine if it's acute or obtuse. And once you know the largest angle, then you can use the law of sines because you don't have any obtuse angles left, and so you don't have to worry about that. The reason you want to do that is with the law of sines doesn't distinguish between acute and obtuse angles, and that's what causes the whole problem to begin with the ambiguous case. So for the law of cosines, what you want to do is, if you're given three sides and no angles, go for the biggest angle first. It's going to be the angle from the largest side. Now we also have an area formula that goes along with this called HERON'S area formula. It's named after a Greek mathematician, and it looks like this. It says, given any triangle with side lengths A, B, and C, so you know three sides, the area is the square root of S times S minus A times S minus B times S minus C, where A, B, and C are the side lengths. S stands for semi-perimeter, and it's the three sides added together and then divided by 2. In other words, it's half the perimeter. So you find S first and then put it into this formula. You studied three different formulas for the area of a triangle. You have the standard formula, 1/2 base times height, and that's really handy with right triangles. You have the sine formula, all three of them, and now you have HERON'S formula. So you have three different ways now of finding the area of a triangle, and usually you're given enough information to be able to use one. All right, let's use the law of cosines. Remember, you're going to go for the biggest angle first, which in this case will be across from side C. So you want to have everything, you want to use the one that has cosine C involved, because that's what you want to find. You want to find angle C. Pause the recording, give it a try, and resume to check your answer. Okay, so we solve for cosine of C, and we get negative 0.05, which means C is about 92.87, so we do have an obtuse angle there. Then we can find the sine of B using the law of sines, and get 48.51, then use the fact that all angles have to total 180 to get 38.62. Now this time we are given two sides, and an angle. It's in between. We want to use the law of cosines. We have sides B and C, and we have angle A, so we want to use the one that solves for side A. Now, after you find side A, you're going to use the law of sines to find the next angle, either B or C. Let me give you this hint. When you have solved for a missing side with the law of cosines, and you're going to solve for an angle now with the law of sines, the trick is you actually want to go for the smaller angle. So it's a little confusing. With the law of cosines, if you're solving for an angle, you go for the biggest. If you've solved for a side using law of cosines, and now you're going to use law of sines to solve for an angle, you want to use the smaller of the remaining two. And again, it's just to make sure that you are left in the end with an obtuse angle, just in case there is one. Pause the recording, give it a try, and resume to check your answer. Okay, in this case, I'm not sure why they actually went for the bigger angle here, but notice that when they did that, they actually had to say, okay, well, there's two potential angles. and then they had to determine which one was going to work. If you used the trick I told you and you solve for angle B first, you wouldn't have that problem. So you want to go for the smaller of the two angles. Okay, now try this one. Think about what we said. Pause the recording, give it a try, and resume to check your answer. Again, you want to go for the biggest angle since we don't have any angles, and we get that that is 92.94 degrees. And then you can use the law of sines to solve for either of the other two, and then the fact that they total 180 to solve for the final answer. Or you could note that sides B and C are equal, which makes this isosceles, which means that angle B and C will be equal to each other. Now try this one. Again, this time we have an angle. We're going to be solving for side B. Then you're going to have to use the law of sines to find your another missing angle. When you're going to do that, remember you want to go for the smaller of the remaining angles. Pause the recording, give this a try, and resume to check your answer. Okay, so here the book did what I suggested, which is they actually found the smaller of the two angles after they found side B. And there was no debate about it. It was pretty easy. And then you just find angle A. Okay, now we're going to use Heron's formula to find these areas. Pause the recording, give it a try, and resume to check your answer. Okay, our semi-perimeter is 18.5. You see here how we put those numbers in. Should have gotten about 43.52. And for the second question, your semi-perimeter is 17.915. Putting in all the information, your area is 52.11.